Wonderful good morning, everybody. I know it's a bit early. Yeah, you probably agree with me on that. But just to put things into perspective, I've been teaching at a university in Malaysia with which we have an exchange program. If anyone is interested in this exchange program, let me know. After your second year, you can go for a year to Malaysia and study there at a university. How cool would that be, huh? The downside is that occasionally at this university, the lectures start at 7 o'clock. So count yourself lucky that we are starting at 9 o'clock, right? Right. I don't think I need to introduce myself. Please don't make any funny comments about Bayern Munich. I'm a bit sore about that last night. The other thing that I need to say is this is a lecture, and for many lectures we have sign-in sheets because lectures are seen as compulsory. So these sign-in sheets are circulating. If you just, yeah. These lectures are compulsory. So please sign in with your name so we know that you've been here. If you miss more than 30% of compulsory classes, like lectures and practical classes, then you probably get an email from the senior tutor and you have to explain yourself why you missed that. No further comments from my side. I have been asked by people what books they should buy for this particular module or what they should read in advance and things like that. Good news is you don't have to buy anything, right? Simply because all the information is out there. If you look at, well, the world's largest search engine, which is? It's Google, yes. Which one is the second largest? Bing. No, it's not. World's second largest search engine? No. 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 YouTube. YouTube is the second largest search engine, right? Apart from China, where it is, I think, where it is blocked. But all the information, all the stuff that we are doing here is on YouTube. And if you really, really struggle finding things, previous lectures that I've recorded are on YouTube. So if you are desperate, I've got a YouTube channel, shameless plug, which is PK11 Kent. You don't have to subscribe, just remember that. And there are all the lectures, there are tutorials, there's all that stuff out there. So you don't have to buy a book, but if you really want to buy a book, if you feel that is a good investment, I suggest something that's called Practical Skills in Biomolecular or Biology. This is for people who really want to have something in their bedroom, although they will never look at it, but it gives a sort of a feeling of comfort. Yeah, I've got the book. Okay? Right. Now, what I want to do with you today is just a little bit of a revision of the concept of mole and molarity. I know that a lot of people have done chemistry A-levels. Who has done chemistry A-levels? Woohoo! Okay, no, that's good. So this will be just a little bit of a review. For those who haven't done chemistry A-levels, hopefully it is a little bit of some new stuff. And the first thing that we obviously we have to deal with is the concept of moles. And with moles, I don't mean these little black furry things that dig up your garden. Mole is just simply a name for a number. So, for example, what do you call two things? Loud? It's a pair, exactly. What do you call 12? It's a dozen. What's a baker's dozen? It's 13, exactly. Why? Is that because bakers can't count or what? Now, they were usually treated as sort of bad people, bakers, because they had the habit of cheating, or they were perceived as cheating. And in order to lose this image, instead of, well, let's say 12 bread rolls, they usually then sold 13 bread rolls, so nobody could accuse them of cheating. And that's why it's called a baker's dozen. Now, in terms of chemistry, in terms of biology and things like that, we are usually dealing with molecules or atoms or something like that. And because these things are damn small, we are not usually dealing with 12 or, let's say, 100 or something like that. We are dealing with very large numbers. And I can't remember when it was, I wasn't around, but there was this guy called Avogadro, who actually came up with some very clever definitions, and also he determined how many molecules are in a certain, have a certain weight. Yeah. Now I think, take my number. Not sure if I want to do that. It doesn't look like a catch, but if anyone wants to swipe right. So what he came up with was, let's call a certain number of molecules or atoms, let's call that something, because that makes it so much easier. And this certain number is basically 6.022 times 10 to the 23 atoms, or in general, entities, molecules, people, rats, mice, moles, if you like. We call this a mole. And this mole is just simply an abbreviation. Instead of saying 6.022 times 10 to the 23 every time we want to talk about something, and try that. Say that 5 times very quickly, 6.022 times 10 to the 23, especially when you're drunk. Try that. It's impossible. We just simply call it a mole. So we can talk about, as I said, a mole of molecules, a mole of atoms, a mole of people, something like that. That makes sense, yeah? So mole is not something horrible or dangerous or scary. It's just a number. 6.022 times 10 to the 23. Obviously, it's a very big number. And the way he determined that was not he was sitting there and counting atoms. He came up actually with a very clever method of measuring how many atoms are actually in a given amount of substance. And this is actually also the official definition of a mole. 1 mole is equal to the number of atoms, and I abbreviate it like that, number of atoms that are present in exactly 12.000 gram of carbon. Why carbon? Well, it's easy to find, and our life is based on carbon, so why not? Could have chosen any other element, but carbon is good. Okay. Now, how do we find actually the number of moles in any other substance? And for that, we don't have to count again. We find this information in the periodic table. Bless you. And the way the periodic table is structured is that it gives you information about how many protons, positively charged particles, are in an element, in the nucleus of an element, and it also gives you more. So, for example, if we look at carbon, carbon sometimes is written as 612 carbon. You've probably seen that in chemistry, yeah? The 6 here means it has 6 protons. This 12 means it has a total number of particles in the nucleus of 12. So total number of particles in nucleus is 12. And in the nucleus, you usually have protons and the other component, neutrons. So this means in this 12, you have 6 protons and 6 neutrons. Yeah, does that make sense? Now this number here actually tells you also how much 1 mole actually weighs. So this number down here tells you how many grams in 6.22 times 10 to the 23 equals 1 mole. That's really clever, actually, because we just have to look at the periodic table and we can find out how many grams do we have to use if we want 1 mole. Just to give you an example, bless you, compound 92-235. Does anyone know what this compound is? Currently very much discussed in the news, especially between US and North Korea. It's uranium, exactly. So this compound actually has 92 protons and 235 minus 92 neutrons in the nucleus. It's quite a big thing. But this number down here, the 235, tells us that 1 mole is equivalent to 235 gram. Yeah? Does it make sense? We usually call this molecular mass of something. Molecular mass. And we say it is 235 gram per mole, or 235 gram per mole. Yeah? Pretty straightforward. Nothing to worry about. We can also say, okay, if I just want half a mole of that substance, well, then I just take 117 grams, because that is half of 235, 117.5 grams, if you want to be precise. And that gives me half a mole. Okay? Pretty easy. Now, usually in biology, in biomedical sciences, in biochemistry, bioengineering, we don't very often... Is that a question? Oh, no, sorry. Please interrupt me at any point, right? We usually don't deal with elements. We deal with molecules. And we can actually very easily find out the molecular mass of a more complex substance. So, for example, we have the compound C6H12O6. What could that be? Could be glucose. Doesn't have to be glucose, could be any other sugar, or could be any other compound. There's a good chance that it is a carbohydrate. You know where carbohydrate comes from? Divide everything by 2. C2. By 6. CH2O. That's where carbohydrate comes from. Carbohydrate. Which is completely disregarding any stoichiometry, but you know that's how it is made up. Okay, so if we want to find out what the molecular mass of glucose in this case is, what we can do is we just simply look at the periodic table. We say we have 612 carbon. We have 1 hydrogen, and we have 816 oxygen. And so we have basically 6 times 12, that's the carbon. We have, for the hydrogen, oops, where's it gone? Hydrogen, we have 12 times 12, 12 times 1. And for the oxygen, again, we have 6 times 16. And we just calculate that, so that's 72, that's 12, and that is 96. And we get, if I've done it right, 180 gram per mole. So 1 mole of glucose is the equivalent of 180 gram if we want to measure that. Make sense? Yeah? Pretty straightforward. Or we can say the molecular mass of glucose is 180 gram per mole. So, big question. One of the things that, where does that come from? One of the things that we very often have to deal with is we have to convert grams into mole and the other way around. Yeah? You have probably done that at school. Have you done that at school? Yeah? Pretty straightforward. What I want to do is I want to show you a couple of methods, how you can very easily do that. Which method you actually use is entirely up to you, as long as you get the right result. And as long as you don't faff around too long, because it is expected that you can do these calculations down quickly. Yeah? So here's a question for you. How many mole are in my garden? How many mole are in 12 gram of glucose? Do you want to try it in the first place? Talk to each other. See if you can figure it out. And we said we have a molecular mass of 180 gram per mole. Oh, have you signed in? Okay, I know that there are people who want to sign in. Oh, I see people writing in the air on the virtual piece of paper, doing triangles, doing all sorts of interesting things. Shall we quickly do it together? I'll show you 3 methods how you can do that. So the first one is we say, okay, we know we have 180 gram per mole, which basically means one mole equals 180 gram. True? Yeah, that is the definition. But we don't have 180 grams. We have 12 grams. Grams equals X mole. Yeah? So it's a sort of, we are dealing with proportions mathematically. So how do we find the X? Well, there's a really dirty trick. We just simply divide these things. So X divided by 1 mole equals 12 gram divided by 180 grams. Yeah? So X mole equals 12 gram divided by 180 grams. We bring that sort of to the other side, mole. So what's 12 divided by 180? So that would be 0.067 0.067 mole. Right? Did you get that? Was easy. We can write that in a slightly different way, can't we? Because I don't like zeros. I mean, if the zeros are in the right place in my bank account, then that's good. But very often you lose a zero or something like that, and you come up with all sorts of weird and wonderful things. Actually, do you know how the zero actually came into existence? Just recently, people found out in an old Indian text that a zero was originally indicated just by simply a little dot. And this dot then became bigger and bigger and bigger, and eventually we were dealing with zeros. By the way, does anyone need the sign-in sheet still? Okay. Come. We can write that in a slightly different way. We can convert that into something a little bit more useful. 0.067 is all right, but maybe we can deal with that in a slightly better way. What we can do is we can use things like milli, micro, things like that. You've heard about these things, obviously, yeah? So what is milli? Milli stands for 1 times 10 to the power of -3, yes. Micro, 1 times 10 to the power of -6. Next one. What is it called? Nano? 1 times 10 to the -9. Next one. Pico? 1 times 10 to the -12. Next one. Femto. 1 times 10 to the -15. Next one. Atto. 1 times 10 to the -18. So these are the common ones, right? So what we can do is to convert 0.067, what we do is we move the comma, and we count how often we move the comma. Let me show you. 0.067. We move this dot here, the point, we move it 1, 2, 3. So it would be 67 times 10 to the, and we moved it 3 times in the right direction. So that would be 67 times 10 to the minus. Minus is right. We moved it 3 times. 3. Yeah? Or, because we said milli stands for 10 to the -3, we could call that also milli. So we have 67 millimole. Yeah? That makes sense? I'll give you some exercises. I'll send out some emails with some quizzes where you can practice these things. Yeah? It's really important that you guys get into that and that it doesn't cause a lot of confusion when you see something like that. Okay, so that was the first method, where we just simply said we are going back to basics and say, what is a mole? What is a definition? It works quite well, but sometimes it's a little bit awkward, especially when you are in a rush. Here's the second method that I've seen people do. So the second method is where people use the triangle. Have you seen the triangle? Yeah? Where you have gram, mole, and mole. Oops, that was the wrong one. And gram per mole. Some people have seen that. Yeah? And the way it works is actually, it gives you sort of an idea what you have to calculate. So we have gram, we have 12 grams. We have our molecular mass, which is 180 gram per mole. And that is actually what we are looking for. The mole. How many moles are there? And the way people do that is they just simply take that out here. And they say moles equals this part divided by this part. So it is gram divided by gram per mole, or 12 gram divided by 180 gram per mole. And that should give us the same result, 0.067 mole, or 67 millimole. Yeah, that's the second method. My problem with this method is I can never remember which one goes in which part of the triangle. And obviously that's a problem. If you put the wrong thing into the triangle, you're royally snookered. Yeah? It's not going to work. So the first method is a little bit clumsy. The second method is prone to errors, because if you put it in the wrong place, it's in the wrong place. Don't get a really good result. Is there anything better? Well, actually there is, in my opinion. Whichever method you use is entirely up to you. The third method is called dimensional analysis. Anyone heard of that? Dimensional analysis? No? It's a really horrible name. I would have called it in a completely different way. And what the dimensional analysis does is it helps you to convert things extremely easily. And the good thing is you don't have to remember any equations. I can't remember equations. I can't remember anything usually. When I come home, I see younger people running around and I think, I know you. Remind me of your name. I think you are my children. Yeah. So for me, remembering equations is a definite no-no. Can't do that. I need something else. And in order to show you what I mean by dimensional analysis, let me do something with you. Dimensional analysis is based on a certain feature. You want 20? Yeah? Yeah? Wonderful. You just made my day. Okay? Trousers down. Here's the 120.
How much does it cost?
Sorry?
How much does it cost?
How much does it cost? With that? Yeah, it's painful. Okay. Let's try again. You want 20? You want 20? Yeah? That is worrying. No. No 20. Oh, I just wanted to give you 20 quid. The message is, I didn't tell you what I wanted to give you. Right? What I deliberately did not mention was the unit. Is it 20 pound, 20 of the finest with the bullwhip, 20 turkey drumsticks, 20 kilos of gold? I didn't say what it is. But, as you just seen, it is absolutely essential that we know about the unit, what we are talking about. Just to give you an example, a few years ago, bless you, NASA and the ESA, the European Space Agency, they worked together to get a probe onto Mars. Everything went well. Probe, we had liftoff. And then 8 months later, people were thinking, flippin' hell, where's our probe? And they missed Mars. Mars, by the way, is a fairly large planet. They missed Mars by several 100,000 kilometers. And you think, how on earth is that possible? It was incredibly embarrassing because they are now drifting some garbage worth several million pounds are drifting in space. Nobody knows exactly where it is. What happened? Well, ESA was under the guidance of the British government, and they measured things in miles. The Americans did it in kilometers. And they forgot to tell each other what the units were. And you think, facepalm, right? What on earth is going on? So units are absolutely essential. How can the units help us here in this case? Well, here are the really dirty tricks. Are you ready for that? Let's say we have a molecular mass of 180 gram per mole, and we have 12 grams. And we want to know how many moles. That was our starting point. We can write this here also as 1 mole per 180 grams. It's exactly the same. Yeah? 180 gram per mole is the same as 1 mole per 180 grams. What this dimensional analysis does is it just simply takes the units and creates the equation for you. How is that possible? Okay, so what we do is, first of all, what is the unit that we are looking for? Well, it's already written here. We have mole. That is the unit what we are looking for. We want moles. Or we can do mole like that. do we have anywhere in on our page here something where there is mole? Yes, we have that. We have that here. And we write it in such a way that this mole is on top. So we write 1 mole per 180 grams. Yeah? 1 mole per 180 grams. So this mole that we are looking for, we write it in such a way that this is on top of the fraction line. 1 mole per 180 grams. Now we have already the right unit here, the right unit, because that is what we are looking for. But we have this pesky 180 grams now in the denominator of this fraction. Can we get rid of the unit grams? Actually, we can, because we have 12 grams here. So what we do is we just simply write times 12 grams. What happens to the grams? They cancel each other out. Hey, look at what have I got now. What is the unit that is left? The unit that's left is mole. And I can write it as 12 divided by 180 mole. Because that's the unit that's left. Hey, wait a moment. Where's the equation? Actually, there's no equation. Just being guided by the units, I did this calculation. It's magic. It's a kind of magic. Okay. My wife always says, Peter, don't give up the day job. Don't audit for X factor. You just simply can't save your life. And she's right. So, this was this dimensional analysis. This is a very, very nifty trick. Let's say we have a molecular mass of 500 gram per mole. I want to know how many moles are in 25 grams. Over to you. Give it a go. Either of the 3 methods is fine with me. You can talk to each other, convince each other that you have the right method. Shall we do it together, quickly? I just do the dimensional analysis. What are we looking for? The unit? Mole. Have we got mole anywhere? Yep, we have it here. So we just simply write it as 1 mole divided by, thank you. So we have 1 mole per 500 gram. Mole is good, so we leave that. We just have to get rid of the 500 grams, the grams unit. Do we have grams anywhere? Lo and behold, yes, we've got grams here, times 25 grams. Grams cancel out. What's the unit that we've got left? Mole. What is the unit that we want? Now we can stop. So we have 25 divided by 500 mole. It's 50 divided by 1,000, so that would be 0.05 mole. Is that right? Yeah? So that would be how many millimoles? 50 millimoles. Simples. I have a substance that has a molecular mass of 238 gram per mole. I need 0.1 mole. How many grams do I need? Want to try it? How do we do that? Again, dimensional analysis is your friend. What are we looking for? What's the unit that we are looking for? Grams, yes. Do we have grams anywhere? Yeah, where? In here, in the molecular mass. So we write it that we have 238 gram per mole. Gram is good. We've got the right unit. Hey, yeah. But it's not a surprise because we just wrote it that way. But, you know, I just thought I should show you some magic. How do we get rid of the mole? We just write. Do we have mole anywhere? Yes, we've got mole here. And so we write it that these two moles cancel each other out. Times 0.1 mole. What happens to the moles? We killed a mole. So what's left is we have 238 gram times 0.1. And even I can do that without a calculator. This would be 23.8 gram. So I need 23.8 grams to get my 0.1 mole. Bless you. Easy. Now, I sent you some links to quizzes. I would like you to try, at least with the first quiz, see whether you can do it. Okay? See you tomorrow afternoon. Enjoy. Oh, wow. I've never got any applause. Hey, thank you.